All right. Hi, everyone. Welcome to the Apping Twilight Tech Talk. Let's collaborate and connect. So let's get started. First of all, what is Apping Club, right? So Apping Club is inspired by youth app innovators and coders, and it is incorporated to have like an inquiry-based learning that sparks imagination and innovation, and we try to unlock your hidden creativity. We try to learn how to create impactful apps aimed at the real-world application. We want you to share your ideas and technology skills with others. We want you to create your apps to solve problems in the whole world, right? Such as healthcare, transportation, whatever. But our main goal is to try to create apps and impact the world. We envision that everyone, despite your backgrounds, can become full and active contributors to tomorrow's society through app innovator, through MIT App Inventor, and such app development websites and platforms. Before I get started, I'll be sharing the link to the slideshow so you guys have access to it and can follow along. All right, looks good. And as always, this is our website, which is appingclub.org. And here you'll find all of our details about our past programs, what we're doing, and what competitions that we're going to do right now, such as the MIT Summer Appathon that will be beginning very, very soon. If you haven't already, feel free to register now. And as you can see, you can find out from our past events in our What's Up, and some of our latest events, news, and such. And on our website, we have some easy access links, such as our Discord and YouTube channel. Also, the event recordings will be posted on our YouTube and our Discord channel, so make sure to join our Discord. In this event, we're delighted to welcome our guest speakers, Kevin Meng and Chung Wu, who are distinguished leaders and aspiring AI researchers. So first of all, Kevin Meng, one of our advisors, a forward-thinking researcher and entrepreneur at like the peak and nexus of CS and artificial intelligence. Kevin is a co-founder at Ember and also a visiting researcher at Northwestern University and also an undergraduate researcher at MIT's CSAIL, or Computer Science and Artificial Intelligence Laboratory. His contributions to the field include developing innovative algorithms in AI, machine learning, and also reflecting his drive to push the boundaries of AI and data utilization. If you guys have already noticed, Kevin actually have won ISEF Special plus Grand Prize 9 times, and he was also the Grand Prize winner for MIT Hacks. So, round of applause to welcome Kevin. We really appreciate you being here today. And our second speaker is Chung Wu. He specializes in big data analytics, technology, cybersecurity, and software observability. He's an active contributor to the educational activities. He also devotes his time to events like ISEF and CSEF. Chung is also a alumnus at UC Irvine and Northwestern University with a degree in information and computer science and also management and engineering. So also a round of applause to welcome Chung Wu. Really, really appreciate that you can take your time out of your day to be here and share insights with all of us aspiring high schoolers. Thank you very much.
Glad to be here.
All right. But with that out of the way, let's get started, right? This is a tech talk in the end. All right, so on our side, we have some other discussion points I will be going over. You can see, these 2 slides. Some of our discussions we will have like some intertwining topics such as about ISEF. But let's get started with Chung Wu. So one of the first questions I wanted to ask you is, how are big data analytics technologies shaping the future of cybersecurity and also software observability? Can you explain more about that? Because I bet a lot of people are confused about just like what those are.
Okay, so first I'll give a short answer and I'll give more details. So in general, big data analytics is helping us to better understand how systems are getting used or misused in the case of cyber attacks. And then we can use the information, the insights that we learn to make these systems more automated and more resilient. That's a high level answer. Let me go into a little bit more details. And because we're talking about the software observability, so first I have to talk about, well, what is software observability, right? When we run applications, in the enterprise, these are massive systems. Some of these systems, I'll give some examples, right? School Loop is an example of that. The system that you use to in your daily interactions at school to find out about your homework and so on, right? More massive systems, airline reservation systems, banking systems, Amazon e-commerce, right? These are systems that have to handle tens of thousands, if not hundreds of thousands of concurrent users. So it's very demanding, in order to be able to serve all these users and provide good performance. And in order to run these things, that you need to be able to monitor what goes on. You need to be able to track how many users are logged on, what they're doing, how much resources all these different users are consuming, CPU, memory, disk space, and so on. And that's the work of software observability, right? It's the instrumentation as well as the analytics in order to figure out what's going on with these systems. And it used to be that the focus of software observability was the basics. Just getting the data was a huge problem, right? Just collecting the data. And then be able to visualize the data was the secondary problem. And then be able to automatically process some of the data. So for example, setting up alerts. Let's say that you see a system and you're running load on disk space, or you are consuming a lot of memory, right? You want to alert the people who are running operations on the systems so that they can do something about it, hopefully. And that was the old way of doing things. Now, increasingly, we are leveraging big data analytics and specifically machine learning techniques, because in some cases, that it's very hard to just set up rules to define what the systems need to behave, right? So we actually want to use machine learning to learn about the behavior of the systems. So on a Monday, for example, right, is there a pattern on how many users would be logged onto the systems and what they're working on? And you may notice that, hey, it's a Monday, or how about Friday? Okay, Friday, people would be off from work, in late afternoon, the systems would be quiet, but all of a sudden you're seeing a spike in activities. What could be going on? Well, that could be an attack. That could be a cyber attack, right? So we can use these machine learning based techniques to detect anomaly so that we can respond accordingly. And the other part of why we need this sort of approach is that you just do not have enough people to run all these systems. There is a huge lag in the number of people that are trained to be security analysts. It's one of the biggest problems that we have in the industry. And in order to really be able to defend these systems, we need automations. And then the other thing is that the idea about using software, right, to make systems more automated, it's not a new thing. IBM came up with the idea of autonomous or autonomic computing back in the early 2000s. And it specified 8 principles and on how you can make the systems to be self-healing, self-running, and so on. And some of those things are still have not, some of those goals that they set out all the way back in 2001 are still not being fully realized. So for example, right, one of the goals that they have is for a system to be able to anticipate the demand that's coming and then be able to optimize resources that are needed to support business operations. And we're barely getting to the point that we're doing predictive analytics so that we can anticipate what the systems may need to scale up, right, in order to support a certain workload. So that's the long answer on how big data analytics is shaping the future of cybersecurity and software observability.
Yeah, fantastic perspective. Also, we know that like right now AI is on the rise, right? So we know that more and more people are starting to use AI into their writing their programs, right? And we also know that C++ is very dangerous because you make a tiny mistake and just basically corrupt your whole system, making the security causing a huge security leak. So knowing that, do you think using AI into the system for cybersecurity, would it be a benefit or would it be the risk? Would it be greater?
So my answer is I'm not sure, because that is still very early in the game. In general, that it's dangerous to include code that you don't understand, right? So people are using the generative AI techniques, to generate code, but do they really know what the code actually got generated, whether it works or not, whether it has security vulnerability or not, right? Not sure. It's still too early in the game. But at the same time, I'm also being hopeful that generative AI techniques can be used to benefit software engineering, because in general, that a lot of software systems are just not getting properly instrumented. They don't have the right set of metrics. They don't have the right set of logs. So there's still a bit too much of a black box. Can't tell what's going on. And, and some of these are really grunt work, right? So some of these works can be generated. Some of these code can be, for the instrumentations, can be generated. That could be a good thing. And another thing is that in general, a lot of software systems don't get tested enough. There's not enough functional testing, there's not enough load testing, and there's certainly not enough security testing. So using generative AI techniques to generate the test cases, right, in order to more comprehensively test the systems before they go into productions should be a good thing. And actually that would help improve the quality of these software systems. So I think that it's still very early in the game. If the verdict is out on whether generative AI is a good thing for software engineering, or it will make these systems be more vulnerable.
Yeah, it's still really early, as we're still on like basically just the beginning of this AI, right? But in general, what are some general trends like you see in like these kind of mistakes that lead to cybersecurity vulnerabilities?
Well, so the general trend, human beings is still the weakest link, okay? And that's because people make mistakes. Sometimes they're very stupid mistakes. Sometimes they're being careless. And let me give you an example, right? So there's a piece of software called LastPass. Okay, it's a password manager. Okay, LastPass got hacked. Okay, and the hackers were able to download all the password that LastPass users entrust to the tool. Okay, and how they did it was that LastPass keep a backup of the password in encryption. Right? Okay, they're all encrypted.
Yeah.
In AWS. Okay, and those backups are also encrypted. Okay, now within the whole company that there are only 4 people with access to the backups, and somehow, don't know how, but the hackers were able to launch very targeted attack towards one of the individuals. And through his systems was able to hack into the AWS backup and stole the cache of all the password and the encryption key. Okay, so totally caught the systems compromised. And how did that happen? Well, so this person is supposed to be an IT professional, security professional, and he made a very stupid mistake of running the Plex media server. Well, he's running it on his personal machine, but he's also using his personal machine to do work. And the hackers compromised the Plex multimedia server, and then they were able to compromise his machine, and then they were able to figure out the rest of what they need in order to hack into AWS. So stupid mistake, right? That the hackers don't have to launch a frontal attack in order to hack into the AWS store. They just got around it by hacking a human being. And part of the problem, by the way, is not just human beings being careless. Part of it, I think, is also a problem of knowledge. And when you look at typical computer science educations today, that we do not teach our students enough about the need to secure systems, about cybersecurity, about operations. There's not enough of that in most curriculum that I've seen.
Yeah. That's why the education is like always, like people say, it's ever like changing, right? We always have to like adapt to like the new environment, especially with like these kind of AI, ChatGPT, all those kind of stuff. Education is on like the brink of another huge evolution in a sense. But moving on, how do you think like with like the application of modern AI analytics, how do you think that could impact some of like the more traditional digital systems such as like automated manufacturing?
Right. So in general, that will make these systems smarter and more automated. Because when you look at many of these systems, so when you talk about manufacturing systems, that typically you have systems for doing scheduling, for doing material control, for doing supply chain management, and these systems could be also connected to front-end systems for doing e-commerce. Because at times, depending on the business model, right, such as like Dell, right, you are doing build-to-order systems. So the front end and back end of these systems needs to be connected. And the traditional systems, we talk about mission critical business systems, that they have solved the most basic problems. They have solved things like record keeping. They have had basic capabilities for forecasting, right? But still, that these are, at the end of the day, these are still tools, and the tools require end users to go in and that beyond capturing data, they have to use the tool and still have to make a lot of manual kind of human decisions. And some of these decisions really that they don't need to be made by human beings per se. If you apply enough machine learning to analyze what goes on, or maybe learn from the human decisions, right? And then the machine can start executing and automating those functions on the human's behalf. So basically, when you look at these software systems, that anywhere where there is a human decisions involved, right, that is an opportunity for automation using big data analytics and machine learning. Now, of course, that there are also cases where it's inappropriate for automation as well. And those are typically cases where judgment calls, where strategy, where human intuition is involved.
Yeah, definitely feel like with the implication and integration of AI analytics probably have a huge change on how these traditional systems will also change, perhaps revolutionize.
Right. Right. And I was just talking about the functional aspects of the systems. Of course, there is also the platform aspects, right? So these systems that they're massive. They these days that they're deployed either in corporate data centers on a bunch of machines, or they run in public cloud infrastructures. And in order for these systems to be flexible, right, to be able to scale up and scale down to respond to different demands, that you also need to make the systems, going back to what I talked about earlier, or the idea from IBM about autonomic computing, that the AI analytics are going to be used more and more in the operation aspects of these systems as well, so that they can respond to changing business needs.
Now, moving on, what do you think the next big cybersecurity vulnerability in huge corporations could be from, and what effects it could be, mainly because of the integration of these new AI and stuff like that?
The thing about security is a constant cat and mouse game, so to speak. That the bad guys will always try to come up with new ideas, and then the good guys need to try to defend against that. So it's a never-ending battle, right?
Yeah.
Between the good and
cat and mouse, basically.
Yeah, it is. And one area that I'm particularly concerned about, quite frankly, is what we call the software supply chain. Okay, what is the software supply chain? So when you look at a typical piece of software these days, and it has been like that for the past 20 plus years, that people don't write software from scratch anymore, right? It's just too time consuming, too costly. So a lot of software development is being done by using existing components, what we call componentized software development. In other words, libraries, right? Pre-built software components. And then when we look back, also another thing that's happened in the past 20 years or so is open source, right? There are a lot of these components are developed and they're shared out in the open. There's open source technologies, which have a lot of benefits. Yeah. But at the same time, that they could create vulnerabilities, right? Because the thing about it is that one of the arguments about open source, and there's some truth to that, is is that because you have a lot of people working on it and you have a lot of eyes on it, right? A lot of people looking at it, that you may be able to detect the security vulnerability faster and be able to fix these problems faster. And there have been studies about how open source software get patched versus proprietary systems and so on, closed source software. The problem is that well, if you're a hacker, that you can try to launch frontal attack against the front door, right? And that's hard. You have to get through all that encryption and security, so on. You can launch social engineering attack to try to trick the users into stupid things and get in that way. But what if you can weaken the systems in the first place, right? So what if you can, in other words, what if you can plant a bug or you can plant a vulnerability in the software in the first place? That's even better, right? And then with all these open source repositories out there and all these contributions, sometimes you have to wonder, well, do you really know the person making the contribution is legit? Or is that an agent, right? Is that an agent from a criminal enterprise? Can be kind of hard to tell. Now, you may think that this sounds like James Bond, it's got spy movie kind of plots. But the thing is that cybersecurity these days has changed from the early days, from the 80s and 90s and so on. Because in the early days, people would hack systems. First, the hackers would do it out of technical curiosity, and then they went into hacking it because they want to have fame. And but these days, most of the hacking happens for economic reasons. That they're going after big money, and there's a lot of incentive for doing that. So you can think of really that the most aggressive way of doing things are on the table. And look at the LastPass attack, right? The LastPass attack was a targeted attack. They were targeting specific employees within a very critical, one of the critical security systems where a lot of people hold their passwords. So if you're trying to hack into a lot of systems, well, that's one way of doing it, is to hack the password store, right? And then you can hack into a lot of accounts. And the way of using software supply chain attack by injecting vulnerability into the software itself is quite dangerous. And it's a problem that I'm not sure if we really know how to solve yet.
Yeah, with like the improving technology, cybersecurity also will become a very important aspect to make sure everyone's data is like, on point and secure. Also, like, some of the research right now go into like BCIs and AI. And then if we're able to, like, I'm saying like big picture, then like if in the future, if human brains we can actually succeed in memory upload, we probably need some good security on those too. Or else
that's right.
You're hacking to people's brains, and that's not going to be okay. But anyways, moving on. I know you have like a lot of volunteer experiences in like education, especially in like ISEF and CSEF, and I know a lot of students here like also are really interested in doing those endeavors. So what are some like insights and tips that you want to pass down?
Well, so a couple of things. First thing is that I highly encourage students who really want to go the extra mile to do high school research projects. Now, doing high school research project is not easy because we're talking about research. And the difference between science fair, between research-based competition and the other competitions such as Science Olympiad or FIRST Robotics and so on, is that the problem is not defined for you. So the first thing is you first have to define the problem yourself. And then it's very important that you define the problem properly, because if you don't do that, the rest of the project basically can fall apart. That you won't be solving the problems that you try to solve. And the thing about it is that it's a very good way to develop multiple skill sets that are really needed when you enter the professional working world. Because doing research is about as close to what we do in the professional world as you can get. And I'm speaking from personal experience that my own science fair project back in high school was the launching point for my career. And my project was in software engineering. I basically created sort of the equivalent of Microsoft Visual Studio Code back when I was in high school. And that was before Microsoft Visual Studio came out. And I have been working in this domain of software engineering. Also, software observability is part of software engineering, right? Ever since then. So it is also a potential opportunity for you to discover your professional interests, and that could be the launching point of your career. And I've seen a couple of students doing that. There was a student of Abington High School in Pleasanton, and her research interest was in computational photography. And she did her project, did really well, went to ISEF also, won awards, and then went on to study computer science at Stanford and did computer vision research with Professor Fei-Fei Li. And then she went on to Google and work on computer vision. So, you know, it's one way that you can get started. Now, the most important thing is not about going, when you go to these competitions, it's not about winning the awards. I always tell the students that I work with that when you go to the competition, right, it's great if you win something, anything, okay? Not necessarily grand prize, anything, okay? It's a nice souvenir. But that's not the most important thing. The most important thing is you have to be able to look yourself in the mirror and be able to be responsible to yourself and answer questions. Okay, have I tried my very best? And if the answer is yes, that's the most important thing, because what you gain is not, you know, it's not the award. You know, the award that I won, the C7 ISEF back when I was in high school, there's somewhere in my house right now. I haven't looked at that stuff for years. The thing that you get is the experience, the mentality, right, of knowing how to compete, knowing not to give up when you run into obstacles. That's the kind of benefit that you will get. That will benefit your entire career lifelong. So that's the key things that I've learned over the years. Now, another thing, and I think there's some parents also listening in. Another thing that I can tell you is this is my own experience of raising my own child. Okay, that so I worked with my own son for 7 years in his various competition, and I was his coach, I was his mentor, I was his research advisor, and that enabled us to build a very good working relationship. And we're able to, you know, I hear parents saying, "Oh, my son is teenager, they don't listen to me anymore." Not that it's perfect, but I have pretty decent conversation with my son all the time, you know, talking about things, and increasingly that, you know, he's now working. Increasingly, we are, and it's also in the tech industry. So increasingly, we talk about industry-specific topics. You know, we are becoming professional peers, right? So I highly encourage all of you to get involved in whatever way you can, right? In working with your child, you know, as they go through their journey of schools and competitions and college applications. And even after they go into college, that doesn't mean that that's the end of it. You know, that you can bring a lot of your experience and help them transition into the professional world. So that's the second insight that I gained from volunteering in these activities. Now, there's one more thing that I want to point out. One last thing, which is in the past 10 years or so, we have seen a phenomenon in science fair, in the computer science related categories, in which there has been a big emphasis on AI or machine learning related kind of projects. And the thing is that also reflects what goes on in the academic world, that there's certainly a lot of research going on in the academic world that are AI projects, and more specifically in machine learning based projects. Okay, there's a lot of that going on. Not necessarily a bad thing. The thing that gets weird is that most of these projects, vast majorities, they are what I call applied machine learning projects. Okay, those are projects that would study things like medicines. People want to find a cure for cancer, or at least detections for cancers, all kinds of diseases, right? So they would be applying computer vision techniques, convolution neural network, and so on, to analyze medical images, right? To find tumors and so on. And that's just one example. In Parkinson's disease, all kinds of diseases are being analyzed by using ML, and that's not a bad thing per se. It's just to the point that, boy, I could go into a science fair competition, and there would be within the entire panel of computing related projects, like 90% of the projects were on these things. And it got to the point of that, we are, in a way, we're neglecting other parts of science, especially computer science. Because computer science, what is computer science? It's not just about programming. It's not just about AI, right? There are a lot of topics within computer science. Cybersecurity is one of them. It's not the more traditional systems area. Things like operating systems, network infrastructures, databases, and so on, as well as areas like software engineering, my research areas, right? They're getting kind of neglected, and there are opportunities to do great projects in those areas, and there are even opportunities to apply AI and apply machine learning in those core computer science areas. So, and to tell you a bit of a story. So 2 years ago, I was on, was it 2 or 3, something like that. 2 or 3 years ago, I was on the panel for ISEF. Okay, and I remember there was a project on user interface research. It was basically a JavaScript library that's optimized for browsers, and there was absolutely no AI ML involved in that project. And some of the judges, when we're judging, they made very interesting. They were kind of delighted to see a project that was not about AI. More traditional area, right, of computer science, human-computer interaction, software engineering. So something to think about as you ponder what project you may want to work on. And so you may ask, well, how do I figure out what computer science project to work on? And basically, what you do is that you need to do background research. You need to read about the area, ideally from professional journals. And there are professional journals on all these computer science areas. They are published mostly by the Association for Computing Machinery, ACM, or the IEEE, right? That both of these major organizations have a very big collections of journals in the different areas of computer science. So check them out.
Yeah.
It's a very long answer. I hope I didn't take too much time.
No, it's perfectly fine. It's really great experiences and insights. Also, really like the idea how you talked about like the AI getting more repetitive, also like the cancer stuff. Like it's very true, like what you said. Because like if you go onto like the ISEF catalog, right, you'll see like every single year, it's just like a bunch of projects on cancer. I think that's why a lot of the parents, like they're like, oh, you see every year there's consistently winners in the final doing cancer. So equals I should have my child also do cancer. Like AI detection cancer so easy. Like they have this idea of leaning on the giant's shoulder, right? So I think that's also affecting a lot of like the reasons why there's so many projects related to like detecting a certain disease, whether if it's cancer, Alzheimer, or something like that.
Yeah, and well, it's a big problem, and we want to solve those problems. It's just that we don't need to have everybody doing projects in that area.
Yeah, exactly. All right, well now let's see, Kevin, what are some of your insights on ISEF from like the perspective of someone who like won ISEF literally so many times?
Yeah, so I have to echo a lot of things that Chung said. It is an experience that is infinitely useful to you, even if you don't win anything. It is a great experience to build a good working relationship with whoever is your mentor, whoever your collaborators, whether that is your parents or not. it happened to be for mine, and I'm happy to report that it went well. So it is a great opportunity for that. Yeah, I don't know. There's not much I could say other than the stuff that everyone says over and over again. But one of the things that I strongly believe is that the journey is much, much more important than at the end. And so it's about the experience of going through or dealing with uncertainty, I would say. It's going to come at you again and again, not just in the context of science fair, but also everywhere else, like applying to school or going through school or making decisions about what you want to do with the rest of your life. You're always going to face these time, social, self pressures, and science fair is like a really good microcosm for all of that. Because at the end of the day, it doesn't really matter. Like even if things don't pan out the way you intend, it's just 1 year from high school and life is long. But you can certainly learn a lot from the process of going from nothing to having something. You know, it's very unstructured. It's a lot unlike school, which is what most of us are probably familiar with. And it's just it's a great way to train another side of your brain that, like Chung said, is going to be ever so important as you grow up.
Definitely, it's about like how we can, you know, learn from this journey and how it can like impact our life. Because
Kevin, you're doing a startup, right? Startup is conceptually it's not that different from science fair projects.
Yeah, absolutely. And a lot of the things that happen right now have very, very close parallels to when I was doing science fair back then. You start and you're basically in the dark. You have no idea what people will respond well to. Everyone has their own opinion. Some people love AI projects and some people hate them. And you have to get to the bottom of why do people love them and why do people hate them? It isn't just that if I see an AI project, I'm going to hate it, or if I see some X type of project that everyone else is doing, I'm going to hate it. But if you try to understand why judges will respond positively to some things or other things, you'll realize some things and you can design your strategy around that. It's a lot of the same stuff with startups. You know, everyone's competitive, everyone's doing the same thing. The problems are all there. And if there's a clear business problem, then everyone's going to want to try to solve it. And your challenge is to ask, well, how do I win? Do I beat them on technology? Do I beat them on sales, marketing? Or do I just beat them based on how hard I work? And these are all questions that I asked myself when I was doing science fair. So like Chung said, yeah, absolutely. It's very similar. And also the last part that's very similar is that I have no clue what I'm doing. So it's been a lot of fun.
Yeah, I mean, like research is about the idea of pioneering this field of unknown, right? Also, definitely like good luck on your startup, obviously. But yeah, it's definitely about this field of like entrepreneurial endeavors and also pioneering this unknown field. Also, like it's about how do you make your idea stand out, right? There's so many like similar ideas in this world, but how do you make yours better than the other ones? Even if it's
Yeah, the thing I'll say about that is, and I see this paralleled across both research and industry, I will caveat everything I'm saying by the fact that I haven't turned 21 yet, and I really don't know anything in the grand scheme of things. So everything I say is just based on very like scattered little pieces of evidence from my life for the past 3 or 4 years. But I have spent a lot of time doing research over the past 3 years. And now I'm spending my entire life thinking about the startup problem.
all right. But anyways, a lot of people probably wonder, like, you did so much stuff, right? So how did you balance, like find the balance between academics and like what you do?
Yeah, I think I kind of remember what I was going to say. To answer your question directly, I did not balance. In fact, I did the complete opposite, which was I turned my life upside down for the one thing that I care about. And I thought about that thing the entire day for months or even years on end. That is kind of how I operate. I find it very hard to balance things. And it's true, like you only have 24 hours in a day and then you have to sleep for 8 of them. And other than that, you have to eat, you have to exercise, stay sane. And then, you know, you have just like maybe between 8 and 12 working hours. And if you're constantly switching between a bunch of stuff, it's hard. So, but what you can do to kind of maximize your ability to do a bunch of different things is a pretty general framework, at least for me, which is I just pursue things that are interesting to me and that are challenging and that are new to me. And I found that just by doing these three things, I have set myself up to do, or to be able to do a lot of different stuff, or like choose a lot of different paths. So
Yeah.
To answer your question specifically, like when I did research for the past 3 years, I basically didn't do anything else. I sacrificed a lot, and some part of me regrets it, but the other part of me is like, I wouldn't trade this experience for anything, because I literally would wake up, I would go to my computer and I would sit there and, you know, chat with my collaborators, take meetings with them, write code, but everything had to do with research. Well, you might ask, like, I was in school, what happened to school? And the answer is that school took a backseat. I took classes that fit my research agenda, that were relevant to my research agenda. So things like statistics and linear algebra, I took. Other things, like for example, systems, I left for later, and I ended up taking a few classes on systems later, but I kind of regret not taking more. It is super cool. So +1 on systems being very interesting, but I absolutely did not balance my life. I actually just went all in on doing research. And now that I spent maybe 2 or 3 years doing it, and we made a teeny bit of progress, I decided that it was time to take another risk and try something else. And so then I basically just blocked everything else out, and now I'm working on this company full time. So I know that everyone has a different way of working, and my brain is kind of like one track. But I find that that works for me, and so I just run with it.
I mean, you know, there's a saying like, it's better to just focus on one thing than focus on a bunch of things, because when you focus on a bunch of things, sometimes you might get nothing done. But
that's not unusual, by the way. In my first science fair project, that involved working 16 hours a day for 9 days for that entire spring break to crank that project out.
Yeah.
And nowadays, there are times when I literally wake up in the middle of the night, 3 to 4 a.m., and suddenly think of an idea, wake up, you know, go into my home office, do some work for 2 hours, and then go back to sleep.
Right.
When you're really into what you're doing, that it tends to happen. And as long as you really enjoy what you do, it's okay.
yeah, that's all that matters, right? If you enjoy what you're doing. I know you wrote like a research paper about mass editing memory algorithms. So what impacts do you think your mass editing memory algorithm will impact like the field of AI?
The short of it is that I have no clue. It's been less than a year since we put that out, and I honestly would not be able to predict. But what I will say is that I think the field is important. So what is this field? A lot of people don't know about it or don't know much about it. It's this field of interpretability. And I think it has pretty close connections with cybersecurity and observability. And you can think of it sort of as like observability and cybersecurity for neural networks, because the word on the street is that neural networks are not understood, cannot be trusted, do this, do that. They like sometimes yell at you and sometimes they're super nice to you, and you can't really pick and choose which one. Just like we have these kinds of weird things with software, we have them at a much bigger scale with AI. In fact, software that is traditionally written, we in principle should be able to understand every single instruction that your code is executing. But it turns out with things like ChatGPT, we have no idea what's going on. I mean, you can write out the equation that represents what the transformer is doing, but the equation involves a bunch of parameters, and you have no clue what these parameters mean. And so the goal of this field of study is to say, well, how the heck am I supposed to trust a model that I do not understand? It's like flying an airplane where you still haven't figured out how physics or fluid dynamics works. It doesn't make any sense. It turns out that in history, engineers have always been ahead of the scientists. Like the alchemists were before the people who structured the periodic table, and you know, the Wright brothers were able to get things to fly before we really understood what was going on. And but it always is the case that once we have the right abstraction or the right structure to think about things, we win and engineering becomes really great. And now airplanes don't fall out of the sky randomly. They're extremely safe, even safer than cars. And to think that this would be possible 100 years ago would have been insane, but it's all because of science. So the field of interpretability is very nascent. In fact, it's been around for quite a while, but no one's really cared because it sucked. Like it's really hard. These systems are extremely complex, and especially with complex systems, much like the human body or the human brain, neural networks are kind of like that in the sense that they're emergent. They have a little bit of small pieces that don't make sense on their own, but then when you put them together, you get something crazy like ChatGPT. They turn out to be very hard to understand. So, I mean, if you ask me, this field will change everything if it ends up panning out. Of course, if it doesn't, then hopefully we've learned a few useful lessons and stuff. But if we do understand what neural networks do, you can think of it like we can fix ChatGPT when it starts spewing wrong things, or we can fix it when it starts being mean to everyone, or we can fix it when it wants to take over the world, or things like that. I don't know. It's up to your imagination. But I think that field is super meaningful. It's interesting. There's a lot of low-hanging fruit. Feels like the early days of trying to reverse engineer what goes on in human bodies and stuff. And yeah, I think it's going to have a big impact on the future.
Yeah, and that interpretability is very important because you need trust in order for these systems to be properly used. And you try to go into enterprise and sell people on these technologies. And people are skeptical by nature, which they should be, right? So make these less of black box is very important.
Sure, absolutely.
But if it does pan out great, then that will be really, really huge because it can allow for much greater flexibility and scalability in order to be able to actually like edit.
Yeah, it's kind of like in SQL language, right? That in old days, originally, the first thing we tried to do was, okay, let's make that thing work, right? Let's make that we can run queries. And then the explain statement to explain the query plan came along, right? So that we could do optimization. It's the same sort of concept.
Moving on, like, what do you think is your favorite field of research?
Oh, I kind of just gave a rant about that. But maybe I can take an opportunity to talk about, I don't know. Okay, so I talked about a little bit about my favorite field of research, but it's a long problem. And I think interpretability will end up being not only one person's life's work, but the life's work of many. It'll take many, many years for us to get where we want to be because we are very far from that right now. I will say, maybe I can talk about some of the things that I'm thinking about from an industry perspective. And, you know, Chung, you can tell me everything that's wrong with my hypotheses because I know nothing about systems and I'm actually extremely inexperienced.
Well, we can exchange notes.
Sure, we can put it that way. But something that I'm very interested in, and it has to do with data, is language models are great. But one of the things that they are particularly great at is they can take data and transform it. So traditionally in big data, we have like tracked a bunch of numbers and we track a bunch of events and we put it in a very structured format. And to be fair, that's great because structure is what makes querying efficient and things like that. But there are certain classes of data that are super hard to query with SQL. And this can come in the form of, for example, Reddit. Like I'm sure everyone in the audience loves using Reddit or Twitter or YouTube comments. And there's very rich data in those comments. Like people are literally telling you exactly what they think about the video or the thread or the topic, the product. And right now, no one's collecting this. I mean, the very basic things that people can do are they can tag some things with some small NLP models. They can do a little bit of basic analysis and try to figure out whether people are doing it, you know, positive sentiment, negative sentiment, these kinds of things. But I think a very obvious, and it's not just me, everyone has this hypothesis that language models will change the way that we look at data. We can, I mean, to put it in a way that makes sense to most people, it's sort of like, what if you could take all the knowledge in the world, and this knowledge doesn't have to be organized. Like this knowledge can just be in the form of things people say on YouTube or things people said on whatever podcast you listen to, or things people are writing on your weird 4chan Reddit threads. Like, what if you could take all of that and have a better understanding of it? That's kind of what I'm interested in. And obviously a lot of people in terms of like this AI thing, they're super excited about autonomy. They think that the language model can act as an agent to do things for you. But I think that's going to have to wait until we have a better understanding of interpretability. I mean, these models aren't very good at being agents yet. They don't have any, okay, I will not claim this, but it's tough to tell whether they have like internal reward structure that mimics human behavior. It's tough to tell whether they can think about long-term plans. So they're not quite at the stage of fully automating everything away. But what they could be really great at is being your knowledge assistant. To say, what if my SQL statement wasn't limited to just direct matches or direct counting? What if I could do a little bit of a more complicated transformation on data? And that's what we're interested in. That's what I am interested in. It's a very practical issue. It's a very hot problem. Like everyone and their mom is thinking about this when they're building companies. But I think it's exciting. I think we have a little bit of a different approach to it. And I think this also goes hand in hand with interpretability because, you know, I'm a startup. Why am I building this? And why am I not worried that Google is going to build this and crush us? And the short answer is it's too risky. What we're doing is we're basically saying we're going to take your enterprise's data and we're going to transform it in a bunch of ways. And then you're going to glean insights from the outputs. Well, like a big enterprise would look at this and be like, what the heck? We can't trust that your transformation actually preserved the essence of the original data. We can't trust this. We can't trust that. There's too many variables that are unknown. Can't do it. And what we think is that regardless of whether it works well or not, there's a huge opportunity here and technology can only get better. So we're going to take a bet that this is possible and we're going to try it out. So to bring it back so that it's relevant to the discussion at hand, it's been a long process to arrive at something like this. And it started with my interest in language models to try to understand what they can do. But also given that everyone is super excited about deploying these, I was also interested in seeing, given what I understand about how limited transformers are in some ways, how can they still be useful to people? And this startup is just one of the things that I landed on.
It's a valid use case. And I can tell you one thing that I'm doing with generative AI technologies, right? So as a product leader, that basically what's my job? My job is to figure out the right product strategy so that we can beat our competitors and make money. Right. That's what the key difference between doing commercial products versus research is. We have to worry about making money and beating the competition. And so one thing I'm using the AI these days is to do competitive research. That at least as a starting point, right? Because it's able to go out and glean so much data and a lot of it's unstructured information, right? On chat forums, in articles and reviews and so on, that I can learn about the strength and the weakness, and as well as what my competitors are doing, right? So that's one use case I'm already pursuing. And then there are also internal corporate data, in customer support, in sales, and so on, that we're trying to gain insights of. And right now it's very manual to do those things, right? So there are definitely opportunity to apply these techniques in order to gain insights, out of the various business functions and enable the people, right? The people who are running the business to make better decisions.
Yeah, absolutely.
I feel like really awkward having to drag us all back to like the actual discussion points. But moving on, what do you think, like, we know that memory recall and transformers are like, also part of the big topics. What do you see some of the opportunities and challenges that might come into this field?
I think the interpretability question is a big one. It's something that everyone markets themselves as having, but in reality, no one has it. Really, no one knows what's going on when they deploy a transformer. And that's a huge opportunity. It's like we have created this super intelligence that we do not understand. I will not call it a super intelligence at the risk of sounding inflammatory, but something that's very smart, something that, let's say in more technical terms, implements algorithms that we were never able to write ourselves. We were never able to write ChatGPT just by writing if statements and while loops and for loops and stuff. We needed this weird sort of bag of linear algebra. So understanding this, I think, would be a really big scientific opportunity, a big scientific challenge. And the most exciting thing about it is that it has the characteristic of every single great scientific question in history, which is, what is the right way to look at a transformer? What is the right abstraction to think about it? What are the right units of understanding that we need? because for things like classical mechanics, math turned out to be a really great abstraction. We have things like Maxwell's equations, we have things like F equals ma, and it turns out that with a little bit of measurement error, these are really, really great models of what goes on in the physical world. And it's beautiful that they simplify to these 5 equations or something like that. And for things, unfortunately, for things like neuroscience and biology, we haven't found the right abstraction yet. Is it to look at it at the molecular level, which is what molecular biologists do? Is it to look at the chemistry of the different things that are interacting? Is it to look at the specific quantum effects of those molecules interacting? Or is it to look at systems, which is what systems biologists do? They look at entire systems of cells or organs or things like that, and they try to make higher level observations about patterns and pathways. So biology is one of these things that's like totally unknown, whether we have the right abstraction for it. And now AI comes along, and it's another one of these big scientific challenges. And it has this property of people have no clue how to look at it. When you talk about an AI being super intelligent, why is it super intelligent? You know, you can go down to the very bare level. You can look at the specific computer instructions on the CPU that it is executing, or you can look at the math, the equations. And in fact, the equations are super simple. Like a high schooler could understand what a transformer is doing inside. But does that mean that they understand why it is super intelligent? Not really. You could look at it as more of at a little bit of a higher level. You know, transformers have layers, you know, neural networks have layers that increase in depth. Is that the right way to look at it? Maybe. There's a little bit of cool research that shows that transformers actually just refine their predictions iteratively through the layers of the network. So maybe that's a little bit of a better abstraction than just looking at the specific instructions on the CPU. But the point is that this is a huge opportunity for anyone who wants to win the Turing Award or wants to win some big prize, because the challenge is so fundamental that we do not even know what question to ask. That is what makes this question so fascinating and so opportunistic for any smart people like you in the audience who might want to figure it out. And then obviously, you know, there's economic opportunity. There is opportunity to use AI for good, and also there's opportunity to use AI for bad. And so I won't frame it as just an opportunity. There's also a big responsibility that comes with developing something like this, because now it has become infinitely easier to spam people with misinformation. It's become infinitely easier to impersonate people or make fake identities or like do a bunch of bad things. And while these sound very trivial and sort of not important, they actually can have big impacts. Like information is one of the most important things to humanity. And if we meddle with that, if we meddle with trust in each other, then that's going to cause a lot of bad things. So yeah, lots of stuff to talk about, but AI, to put it simply, is exciting, but also we have to think carefully about it.
Yeah. Definitely, there's like a lot of problems that come with any technology. But also another big concept that people worry about, you probably know, it's like people say with AI developing so fast, right? It's probably going to create another societal gap, just like how any other previous revolution have done. Just like in the Industrial Revolution, people talk about Industrial Revolution all day long, talking about steam engines, electricity, let's go. But what about the class difference that widened between the middle class, right? So with like this AI developing so fast, how do you think it will be possible to equally distribute like the resources equally, especially for like, you know, these AI systems, and how can we try to like minimize the societal gaps that it will bring?
Yeah, very good question. And I'm probably the worst person you could have asked about it, because I only figured out really what capitalism was a couple of years ago. So it's very difficult. Very recently, Bill de Blasio, former mayor of New York City, showed up at MIT, and he was like, ChatGPT is real. It's a thing. What do we do about it? And regulation is a big topic right now amongst politicians. How do you regulate this thing? Some people think there should be an FDA. Some people think that the government should limit the number of jobs that can be cut if AI automates things away. Some people think it doesn't matter, and you can just do whatever you want. So everyone has their own opinion, and it certainly is very tough. I think I'll maybe defer to people like Chung, who have been around for a little longer, and have witnessed things like the software revolution, or like you said, the industrial revolution, although we weren't around for that. But I think it's worth looking back in history and drawing parallels and seeing or asking the question, this has certainly happened before. Like when software was eating the world, I'm sure a lot of people realized that their jobs are being cut. And I will not claim to fully understand the ramifications of that and what kinds of good things it caused and what kinds of bad things it caused. But I certainly agree that it's something we have to think about.
Yeah, that's what I've been doing in the past several decades, really, is work on various software tools. And one of the themes, one of the purpose of those tools is to improve the productivity of software developers and IT operations professionals. And it's always that, the one way to look at it is productivity, but whenever your productivity, there's always the risk of displaying someone's jobs. Yes, you're taking that function and then you're making it automatic, right? So at the surface, you're automating someone's job. But at the same time, we also see that software has increased its use by so much that we're actually creating a lot more software, and the demand for software professionals has actually gone up, right? So there's that impact. But I think overall that how the resource will need to be distributed. I think we need to look at it also from a meritocracy perspective. That the thing is that this country is founded on the principles that there are opportunities, right? Is equal opportunities, doesn't mean equal outcome. And for people who are willing to try hard, they're willing to burn the midnight oil, that those people should be rewarded, right? And we should not reward people who are not willing to even do the basic work. And one thing about the tech industry, so that if you want to stay relevant in the tech industry, you have to constantly learn. And right next to me right now is this is just a partial set of books that are on my reading list right now to keep up, right? And I've been in the industry for several decades. I'm still learning. So I think the problems that we need to solve, yes, that there will be job displacement, and there will especially for job displacement for people who are not willing, who are not willing to learn and improve themselves. And we have to, look at it from a societal perspective, that what sort of incentive do we want to create for people, right? Because if we just let people make money without doing any work, that's going to create problem as well. So that's my thoughts.
Well, humans are always learning, and we should always be learning anyways. Books, great way. Books are stories. Books are the essence of what someone you spend their life to capture, right? But anyways, as we have the conclusion, I wanted to wrap up with a question about how do you see the role of app developers evolving as AI become more central in creating apps? Because we are an apping club, right? So we still have to talk about apps.
Well, so the way that I see it is that we have been trying to make developers more productive. In the 90s, we came up with the idea of componentized software development. So you have to write all the code from scratch. There have been developments for case tools, for the more recent things, the low code or no code trend, right, of development tools. Pre-built applications, package applications. These are things that just some of the things that the industry has done in the past several decades to make it easier and faster to build applications. Yet the demand for software professionals have gone up, and that's because software is eating the world. It's getting to everything, and we need software that, when we look back, I think 10 years, 20 years from now, and we look at the software systems today, that what we thought are very advanced today will be very primitive by comparison, right? So one of the things that we should be able to do with AI is to increase our capabilities so that we can create more complex systems, systems that are more resilient. That maybe we'll be able to realize the vision that IBM laid out for autonomic computing. That's one thing that I see on the positive side. Now, of course, that people will have to adapt the skills. That coding the same old way, probably won't cut it, right? People have to learn to use these tools to the benefits.
Yeah, developers gonna have to change, and as you said, learn constantly and adapt to the new changes. Even though I don't know anything, but I definitely feel like coding is gonna be like changing like really, really fast and very soon.
Yeah, something I'll add to this is that while there is a lot to learn, there's also a lot to rejoice about. And it has the feel of this, like Chung says, this componentized software development, in the sense that even though a lot of stuff is already put into libraries, today you still have to rewrite a lot of stuff that people have written so many times over. Like if I want to create a website, obviously there's this cool thing called Tailwind that can format it nicely for me, or some other thing that can serve a backend, but I still need to write those hundreds of lines of code, and it's really annoying. And what ChatGPT is really great at doing is to do things that no one wants to do. So you might be thinking, okay, well then AI is just going to eat software development. And I don't think so, because what this really does is it opens up the opportunity for you to do things that no one has done before. And it opens time for you to think about what you could do differently, how to design interfaces differently, how to do this, and that. And it should feel really exciting that you don't have to redo a lot of the work that people have done.
Yeah, like I think like rather than thinking about coders and software like engineers getting just like demolished, I feel like it'll be kind of like a transferring into another type of job, because after, as you said, if ChatGPT is able to handle all those quote unquote annoying works, then there will be a new type of developers, perhaps not called software engineers, something else, and those will be handling how to use the AI to write code.
Yeah, I guess it's complicated because the whole point of software is that you understand exactly what's going on. So we're going to have to build new user interfaces. We're going to have to think long and hard about how these two diverging views on how software should be written can be reconciled.
But anyways, as our time concludes here, just wanted to say like thank you for actually joining in and taking your time out of your day. I know like both you and Chung is probably like really, really busy, and I really, really appreciate you taking the time out of your day to be here. So like today was a great discussion, and I hope everyone who came out learned something new, gained some insightful knowledge, and just once again, thank you very much for Mr. Wu and Kevin for being here.
You're welcome.
But as always, hope everyone have a great day and good luck in everything.
Yeah.
Yes. Thank you, Kevin and Chung. Really appreciate it.
All right. Thank you, everyone. See you all in the next event.
Bye-bye.
Bye.
Bye.